Hey Google, what's the weather today?
Tonight's forecast for Guwahati is 26 degrees and clear.
Pretty cool, right? But have you ever wondered how this Google Assistant or any voice assistant can understand our language or even respond to us like this? Well, that's where something called Recurrent Neural Network or RNN comes in. From voice assistants to language translation, this RNNs were and in most cases still are the key building block for all the sequential related tasks. Obviously, today the transformers and the transformer based models have hugely taken over. But this RNN, they have laid the foundation, the groundwork of how machines handle the sequential data. Sequential data like speech data, text data, or the time series data. So, in this video series, we will explore what RNNs are and why they are needed. That is, in the first video, which is this one, I'll give you an intuitive understanding about the RNN. That is what they are and why they are needed. Second video, we will look at the different types of RNN, their architectures and their real-world applications. In the third video, we will dive into the forward propagation, where we will derive the key equations for the hidden states and the outputs. In the fourth video, we will break down the backward propagation and derive the gradient equations that are essential for updating the model weights. Finally, in the fifth video, we will discuss the major challenges RNNs faces and why newer models like transformers have emerged. So let's get started. Hey Google, play the intro music.
Playing an intro music in 3, 2, 1.
I hope this video series will be useful for you. Let's jump into it.
The world we know as of today is full of data. Data is everywhere. Now, this data comes in many forms. It can be tabular, it can be images, videos, audio, text, etc. Now, once we have this data with us, for any machine learning or deep learning task, we need to first analyze this data to find some hidden pattern of this data, to find some hidden insight of this data. And from that, we need to build a model out of it. Now that model will be used to make future predictions. Like for example, for this tabular data, we often use artificial neural network. Tabular data like spreadsheets or databases, we use models like artificial neural network. For data like images, video and audio, we mainly use model like CNN, convolutional neural network, because the CNN are great at recognizing patterns in spatial or pixel based data. For text data, which is the core of natural language processing task, which deals with sequential data, we use models like RNN, LSTM, transformers, and transformer based models. This video is about RNN. Now, before we discuss anything about RNN, let's first see what is sequential data. Sequential data is the data where the order or the sequence of the data matters. Like for example, if I take example, say a cat is chased by a dog. This is our sentence. In this sentence, this is the subject and this is the object. Now if I change the subject with the object, just swap the subject and the object, then I get a sentence which is a dog is chased by a cat. Now you can clearly see this two sentence. Just by swapping this two word, I'm getting a new sentence with of different meaning. So this is the reason why order or the sequence matter in our data. Now to deal with this kind of data, we need a different model which is RNN. Now one can ask, what special feature does this RNN has that it makes it a good fit for sequential data? So a special feature that RNN has is the ability to retain the memory along the sequence. Now one can ask, how RNN can retain the memory along the sequence. To understand this, first we need to understand what does RNN stands for. We all know it stands for Recurrent Neural Network. So at first, we're going to see the workflow, a simple workflow of this neural network, and then we are going to see the workflow of recurrent neural network. So suppose this is a neural network, or this is a neural network with 3 neurons. So if I pass an input to this neural network, then it will give us the output. This neural network or a neural network layer will process this input and it will give us the output. This is the most simplest workflow of a neural network. This was about the neural network. Then what is recurrent neural network? The word recurrent stands for occurring repeatedly. That means something is occurring repeatedly, and the something is the neural network itself. That is, this neural network will occur repeatedly for different timestamp with different input. That is, this is the timestamp t equals to 1, this is for t equals to 2, and this is for t equals to 3. So this neural network will occur repeatedly for different timestamp for different input. Let's see how the input will go one by one for this neural network. Let's say at t equals to 1, we've provided an input x1. So this neural network will process this input and it will give us the output O1. Okay. Now, along with O1, it will give us one special thing. And the special thing is that thing that makes this recurrent neural network, that gives this recurrent neural network the power to retain the memory along the sequence. And that special thing is H1, the hidden state. This hidden state is a vector or it can be a matrix which stores the information about the previous input x1. Now this h1 will be passed to the next timestamp, which is t equals to 2 with another input x2. That is, you can see that this timestamp t equals to 2 has given two input, has been provided with two input x2 and h1. So this x2 and h1 will together give us output O2 along with a hidden state h2, which is again going to be passed to the next timestamp t equals to 3 along with a different input x3. Now it will give us the output O3. Now from this we can see some observation that this O1 stores the information of x1 because only x1 has been passed here. Okay. This O2 stores the information about x2 because x2 has been directly passed to this neural network where O2 has been generated. So O2 stores the information of x2 and also O2 stores the information of x1 because this h1 has been passed here and this h1 carries the information about x1. So O2 has the information about x1 and x2 and x1. That is, this O2 carries the information about all the input, all the previous and the current input. Similarly, this O3 will have the information about x3, x2 and x1, all the previous input. This O3 will also have the information about all the previous input. So this is how memory is retained along the sequence in RNN. So this was the simplest explanation about the workflow of RNN. Obviously, this is not a detailed explanation. The detailed explanation we will be seeing in our next videos, where we will discuss the forward propagation. There we will see that how the input this neural network processes, how the hidden states are calculated, and how the output is produced. There we will derive the equations of hidden state and the output. So that video will give you the mathematical intuition about how the memory is retained. So this was just a simplest explanation about the workflow of RNN. So this was about how memory is retained along the sequence in the RNN. Now one can again ask that why we need to retain the memory along the sequence. What is the need for it? Why we need to do it? And the answer is to maintain the context of the sequence. To maintain the context of the sequence, we need to retain the memory along the sequence. That means to generate a contextually correct output, we need to maintain the context of the sequence. Let's understand this with the help of an example. The example which we are going to take is next word predictor. We all have came across this feature of Google Keyboard, where we provide a sentence and that Google Keyboard will give us the output, the next word in the sentence. Let us assume that that next word predictor is using a RNN based model to predict the output. Say in that case, if I pass an input, Python is popular for. So this is my sentence. If I pass this as an input to our recurrent neural network, then that recurrent neural network will give us an output, a next word for this sentence. And that next word will be that word that will be contextually correct, that will be contextually good fit for the sentence. Let's say that RNN has predicted the output ML. We can see this ML is a contextually good fit for the sentence because this ML is contextually dependent in one of the word of the sentence. Let's say instead of Python, we have a word JavaScript. So we have provided JavaScript is popular for as a input sequence to our RNN. Then in this case, that RNN will give us the output instead of ML, it will give us the output WebDev. So you can see just by changing the input word, the output word also changes. That means this output word WebDev is contextually dependent on this word JavaScript. This is the reason why we need to maintain the context of the sequence to generate a contextually correct word in our sequence. So this was the reason why we need to maintain the context in the sequential data to generate the contextually correct output. This is the reason why we need RNN for the sequential data, because it has the ability to retain the memory along the sequence. This marks the end of this video. I hope this video was useful for you. Thank you so much for being there till the end.